Sketch a graph of f of x equals 8 minus x squared for x less than or equal to 0, and use this to sketch a graph of f inverse. Then use this graph to find an equation for x inverse. So here we're looking at f of x equals 8 minus x squared. There's a couple of ways that we can look at this. We can look at this as a transformation of the parabola y equals x squared, or we can make a table of values. Either one works. I'm actually going to make a table of values because specifically we're looking at the values less than or equal to 0, and I think that's just a little bit easier. So what we're going to do is we're going to look at 0, -1, -2, and -3. When x is 0, we've got 8 minus 0 squared. 8 minus 0 squared. 0 squared is 0, and 8 minus 0 is 8. When x is -1, we've got 8 minus -1 squared. -1 squared is 1, and 8 minus 1 is 7. Then when x is -2, we've got 8 minus -2 squared. -2 squared is 4, and 8 minus 4 is 4. And then lastly, when x is -3, this is 8 minus -3 squared. -3 squared is 9, and 8 minus 9 is -1. So we're at 0, 8, -1, 7, -2, 4, -3, -1. We could even do -4. This is 8 minus -4 squared. -4 squared is 16. 8 minus 16 is -8. And so we've got -4, -8, which is all the way down here. And we've got this beautiful half of a parabola that looks like this. If we didn't restrict the domain to numbers that are less than or equal to 0, we would have the other side of the parabola over here, but then it wouldn't be a one-to-one function, and it wouldn't have an inverse. So this restriction is required to turn this into a one-to-one function that has an inverse. Now we know that we need to reflect each of these points across the line y equals x. We can either draw in the line and do that, or we can just switch the coordinates. And I'm going to switch the coordinates to make our life easier. Instead of 0, 8, we're going to have 8, 0, which is right here. Instead of -1, 7, we're going to have 7, -1, which is right here. Instead of -2, 4, it's going to be 4, -2. Instead of -3, -1, it's going to be -1, -3. And instead of -4, -8, it's going to be -8, -4. And so we've got all of our points, and we can draw in that nice half of a parabola. And this gives us the graph y equals inverse function of x. I forgot to label the original one. This is y equals f of x. And now we want to find an equation that models this. We want to find an equation for this inverse function. And we can see that this looks like a square root function that has been modified quite a bit. So usually the square root function is up here. Let me draw it. Let's see. It usually looks like this. But what has happened is it looks like it has been reflected horizontally and then shifted to the right 8 units and then reflected vertically. So we've got a lot going on here. Reflected horizontally and then shifted to the right 8 units and then reflected vertically. So if we take the function f of x equals the square root of x, which we've seen before, if we reflect horizontally, that requires replacing x with the opposite of x. If we shift to the right 8 units, this requires replacing x with x minus 8. And if we distribute that negative on the inside, it's going to be the square root of the opposite of x plus 8. And then if we reflect vertically, that requires replacing our function with the opposite of the function. So in this case, through a series of transformations, it looks like the inverse function is given by the negative square root of the opposite of x plus 8. If we want to, we could also do this algebraically to double check our work. And I actually would really like to do that because I am not 1000% sure that I've got that right. So if we take our f of x and replace it with y, this is y equals 8 minus x squared. Then we switch the x and the y, x equals 8 minus y squared, and then we need to isolate the y. So I'm going to subtract 8 from both sides. That gives me x minus 8 equals the opposite of y squared. Then to get the y squared to be positive, we can divide both sides by negative 1. That gives us negative x plus 8 equals y squared. And then to get the y alone, we need to take the square root. But we remember that there's 2 square roots, the positive and negative square root. But because the domain of our original function was less than or equal to 0, the range of our inverse function is going to be less than or equal to 0. So we need to take the negative square root. And would you look at that? This matches up with what we have from our series of transformations. And so everything matches up. In the end, I think it's actually a little bit easier to use algebraic methods to find the inverse function instead of geometric methods, looking at the reflection and then dealing with all of these transformations to get the square root of x over to our inverse function's graph. However, there are situations where algebraically it's far too complicated and all we can actually do is look at it graphically. So being able to do this both ways ends up being useful for us depending on the situation.